Hello all, I welcome you once again for my session on operations research. So in the previous video we have seen how to formulate a linear programming. Okay, so today we will see in this session how to solve the linear programming. So there are two basic approach as far as solving linear programming. First one is graphical approach, second one is simplex method. In this session we detailedly see how to solve linear programming using graphical approach. Okay, so there are two methods to solve a linear programming using graphical approach. The first one we call it as corner point method, and the second one we call it as isocast method. So in this session we talk about how to solve this linear programming using graphical method, that too with the corner point method. Okay, so there are four basic steps we have to follow. The first step is we have to create a mathematical formulation if it is not given in the problem. So I hope you might have known how to formulate a linear programming as we seen in the last session or last video itself. Okay, so with that we'll move on to the next step. Okay, so we assume that there is a formulation or linear programming formulation available, so that we will continue the problem. So now we have to plot the graph using the given constraint, and we have to find out the feasible region. That is the second step. Okay, so keep in your mind when you're plotting the constraints in the graph, when you're plotting line in the graph, the number of lines you are drawing must be equal to the number of constraints. Suppose if there are 3 constraints available, then you have to plot 3 lines in the graph. Okay, so with that base we have to draw lines, and we have to find out the feasible region. So to find or to plot the lines in the graph, you have to first find out the coordinates. Okay, so you have to find out the coordinates for each and every constraint or every line. Then you start drawing the line in the graph. Then the third step is, after confirming the feasible region, you have to find out the coordinates of the feasible region or boundary region. Okay, so feasible boundary region, we have to find out the coordinates. Then after finding the last step, after finding the coordinates, you have to apply the coordinates, or you have to substitute the coordinates in the objective function, which is called as z maximum or minimum based upon the problem. So now what we do is, we will take a basic problem and we will try to solve the basic graphical method using corner point. Okay, I will show you an example. So here is a typical example. So you can see that z equal to maximize z is equal to 8x plus y, which is subject to constraint of x plus y less than or equal to 40, and 2x plus 5 less than or equal to 60. Okay, so these are the two constraints. So as I said earlier, the first step is you have to formulate a problem. So the problem is given here, so no need to formulate it separately. So what we have to do is we have to proceed to the next step. So since there are two constraints, as I told you, the number of lines you are going to draw in the graph depends upon the number of constraints. So since there are two constraints in the problem, what you are going to do is you are going to draw 2 lines. So for which you have to find out the coordinates of each and every line. So I will tell you how to find out the coordinates. For example, if you take the first one, x plus y less than or equal to 40. So you have to take it as x plus y which is equal to 40. You have to take the constraint like that, x plus y equal to 40. Now substitute x is equal to 0. So you will get automatically y is equal to 40. So the first coordinate will be 0, 40. Similarly, for the same line, now substitute y is equal to 0. You will get x is equal to 40. So your first coordinate of line is 0, 40 and 40, 0. These are the two coordinates for your first line. Similarly, for the second line, you substitute x is equal to 0 and first find the first coordinate, and substitute y is equal to 0 and find the second coordinate. If you do so, the two coordinates will be, one will be 0, 40, the another one will be 30, 0. So these will be the two coordinates. So once you find Once you find the coordinates, you can draw a graph like this. So drawing a graph, you can take scale. So your scale depend upon the values, you can take scale and you can find and you can draw the line. After drawing the line, you find the common feasible region for both the lines. Suppose if it is maximum type of problem, you will have a boundary. On the other case, if you have minimum type of problem now, most probably you will not have the upper boundary. Here if it is maximum type of problem, so you have an upper boundary. So here the feasible region boundary coordinates are 0, 40, 20, 20, 30, 0. So what we have done is we have found out 3 different coordinates from the given problem, okay, by drawing the graph. So after finding boundary, so you can also take one more coordinate as 0, 0. So the total feasible region boundaries, one is 0, 0, another one is 0, 40, another one is 20, 20, another one is 30, 0. So 4 different, you can also name it as A, B, C and D. So this is how you are going to find out the coordinates for the boundaries or feasible region. So this is the third step. So once you have found out the coordinates for the feasible region, so what you have to do is you have to substitute these coordinates in the z function. So z function is the first one or first function we have given in the linear programming. So our z function is z is equal to 8x plus y. Okay, so what you do is you substitute x is equal to 0 and y is equal to 0. This is the first point, first corner point which you have taken from the graph. You can see from here. So 0, 0. So you can take this. So substitute 0, 0 in the z function. Ultimately what you get is 0. Then the second boundary point from the graph is 0, 40. So which is given here. So you substitute this in the function, z function. So 8 into 0 plus 40. So it also gives 40. Then the third function you are going to substitute 20, 20 for x is equal to 20 and y is equal to 20. 8 into 20 plus 20. So 8 into 20 is 60. 160 plus 20 is 180. And the fourth one is 30, 0. So 8 into 30 plus y into, y is 0 here. So 8 into 30 is 240. So what you have to do is after finding the values or after substituting the values in the z function, we have to select one point among the 4 points. So all these are feasible points, but we want optimum point. Okay, remember we want optimum decision variables x values and y values. Okay, well, so optimum is different from feasible. Okay, so all these 4 are feasible boundary points, but we want optimal. So among these 4 values, we have to select the best one. So how to select the best one? We have to see the objective of the z function, whether it is z maximum or z minimum. So our problem says z maximum. Okay, so our problem said z max is equal to, or maximum z is equal to 8x plus y. So what we have to do, among these 4 values or 4 outputs of z, we have to take the maximum value. So our maximum value is at the point or feasible point 30, 0. Okay, so our maximum value is at the point 30, 0. So at this point 30, 0, you will get the best result or best profit. Okay, so what you do is, so you have to decide the variable now. So at 30, 0, our profit is maximum at, or a profit is 240. Okay, so what will be the decision variable now? Among the all 4 points or 4 corner points, you take the 30, 0, which is x is equal to 30 and y is equal to 0. Okay, this is how we have to solve the maximization problem. In the case of minimum, the same steps you are going to follow. So only difference is the last step. So what you do is, instead of taking the maximum value among these boundary points, okay, so it depends 0, 0, 0, 40, 20, 0, 30, whatever it may be. It depends upon the type of problem. So if it is z minimum, among the 3 or 4 boundaries what you are going to get from the problem, you select the minimum value. So in the maximum case, what you have done, you have selected the maximum value and you have taken the corresponding decision variables as the point. But here you are going to select the minimum value and you are going to decide the value. Suppose for example, here if it is z minimum, I am going to select 0 comma 0 as the point. Okay, x is equal to 0 and y, but most probably in minimum z minimum you will not get origins 0 comma 0. Okay, so please do take care. So the only difference is deciding on the objective function whether it is maximum or minimum. So you also will get difference in the graph also. Okay, so if it is maximum you will get upper boundary. Okay, you will get the upper boundary, but if it is minimum cases we will not get the upper boundary. Okay, so we are going to have at least value. Okay, we don't know what is the utmost value. Okay, you know the difference between what is at least and utmost. Please to understand the difference and do. So the four important steps as far as graphical method is: first make sure you have a formulation problem, then you are going to plot the graph. Okay, for plotting the graph you find the coordinates, then the third step is you have to find out the coordinates of the feasible region, and the fourth step is you substitute the feasible coordinates of the feasible region in the z function and you find out the decision variables and the values of the z. So this is how you have to do the graphical approach and you have to solve the linear programming problem. Hope this session will be useful for you. Okay, for further details we will meet again in the next video. Thank you.